Hello, this is the second video for the flame test lab, Who Killed Pineapple Willie? So this is going to be on the back side of your notes. We are doing the flame test lab and this big dilemma has occurred. Pineapple Willie has been killed. So we are assigned the task to figure out who killed Pineapple Willie. We have these different suspects that are going to be represented by different ions. And we're going to have to figure out who killed Pineapple Willie. But first, we need a little bit of background information. So, okay, I added this slide in. This is not part of your notes, but it's super important. So, every element on our periodic table that we have seen will emit a certain color of that visible spectrum. So we've talked about visible light, how it has its unique properties of frequency and wavelength. Every element on our periodic table will emit a certain color. We often call these the fingerprints of that element because they're the special characteristics of that particular element. So, going back to your notes, the amount of energy in each photon will determine its color. Okay, so how much energy that photon of light contains determines the color that we see. Red is going to be the lowest amount of energy, violet being the highest amount of energy, and that energy just increases through the rainbow. So red all the way up to blue, indigo, violet, our energy is increasing. There are photons that are emitted that are higher and lower than those wavelengths and those frequencies, but we can't see them with our eyes. We can only see that visible spectrum, red to violet. So what is happening on the atomic level? So electrons, we know they are in certain energy levels or certain rings, okay? However, these electrons can jump to different rings, and when those electrons temporarily jump to another ring, we say that that electron is in what's called an excited state, okay? Sorry about that. My dog started barking at something outside. I had to get him under control. So anyways, electrons are in that excited state whenever they occupy a higher energy level. Now, that an electron, how does it get to that higher energy level? Well, it can absorb energy, so it's given extra energy if it absorbs a photon, or if it, maybe, it collided with an atom nearby and absorbed some of its energy. Okay, so that electron gets to an excited state. However, they will not stay in that excited state for very long. They're going to come back to their ground state, but when they return to their ground state, you can see that this photon of light, photon is essentially just a pocket of light energy. A photon that has that same amount of energy has been released. All right, and here's a little image showing you, absorption of energy. So up here, it collided with, another atom or another pocket of energy from somewhere. It jumps to this excited state. It stays in the excited state for so long, and then when it comes back to its ground state, that same amount of energy is released, and that energy, that's called our photon. All right, when electrons of certain atoms return to that lower orbital or the ground state, the photons they emit have energy that are characteristics of that atom. This gives each element its unique fingerprint. So this is what I was saying in the beginning of your notes, that every element has a specific amount of energy that it's going to release, and that is what makes them unique. So here, this is really cool. So this just shows you electrons that are at different energy levels, okay, or different orbitals, we've called them. And it shows you how their energies correspond with different colors on our electromagnetic spectrum. So I think this is really cool. This will show you, okay, if I'm jumping from 3 to 2, I might emit a certain amount of energy that corresponds with the red spectrum. Or here, this electron jumps from 4 to 2. However, it emits an amount of energy in the blue-green area of our spectrum. So I think that's really cool. So what are we doing in this lab? We can view the spectra of visible colors with the naked eye. It's going to appear to be that color. Okay? So different elements will give off a different amount of light, and that those different colors are going to help us figure out who killed Pineapple Willie, okay? Who did it? Okay, so this is going more with atomic spectra. So absorption is when energy is added to an electron. Okay, so absorption is when energy is added to an electron, and the electron moves from lower to a higher energy level. We say that it has absorbed energy. Emission is the opposite. Emission is when electrons go back to their ground states, they fall, and a photon is emitted. Okay, so I'm going to pull up that picture again. Here we go. Absorption. Again, we absorb energy, go to a higher state. Emission, we are going back to the ground state, but we emit a pocket of energy. Okay. The energy of each absorbed emitted photon corresponds to a particular frequency. And here we have Planck's equation again. Energy is equal to Planck's constant. That's 6.63 times 10 to the negative 34th times its frequency. All right. I think this is really cool. So this is showing you the hydrogen absorption spectrum. So you can see when hydrogen absorbs energy, in our visible spectrum, we've got these spectral lines. Okay, and so this is specific for hydrogen. When it emits energy, we see that it emits the exact same colors that it absorbed here. Okay, so this is saying the hydrogen alpha line, 656 nanometers, a transition from energy 3 to 2, so going from the third orbital back to the second orbital. So, pretty cool. You can identify then the element just looking at these lines. Okay, in this lab, we are going to record the color of several metals that different suspects used when they killed Pineapple Willie, okay? So we have 5 different suspects, and they all have different ions that are associated with them. So we're going to put the ions, which is just going to be a metal salt, on a Q-tip. Originally we used wooden splints, but we're going to use Q-tips. We're going to put those into the Bunsen burner flame. When we put them in the Bunsen burner, we're going to record what color they emitted. We're going to use that data to collect and identify an unknown solution. This process is very similar to the procedure that chemical labs use to identify any kind of contamination or spill or landfill from industrial sites, etc. So this is very applicable to what is going on in the real world. I hope you enjoy this lab, and remember that this does involve a flame, so we need to remember our procedures for using a flame. I'm going to demonstrate that procedure again to you guys, and we've got data tables that we'll need to record results and figure out, again, who killed Pineapple Willie. So if you have any questions, please let me know. Most important things from this that you are going to need to know is what it means to be absorbed, what it means to be emitted, the difference between ground state and excited state electrons. 2 very important things there.